Test. Okay, so I've got some temporary audio here. Let me see if I can. Let me see if I can fix my Yeti. Boop. Okay, test. Can you hear me now? Can you hear me? Fantastic. All right, thanks, Gudmuds. Yeah, drivers, man. Drivers are hard. OBS, I don't know why, but it forgot my Yeti setup, my mic. Okay, so let's start this over. Okay, so the last couple of weeks we designed this GPS and sensor tracker, right? And it had core compute module, BMI 270, accelerometer, BME 688, temperature, pressure, humidity sensor, GPS, e-paper display, solar charging, and a battery. And last week we did the PCB layout, which was fun. And this week, what I'm going to do is I'm going to start in on kind of some industrial design. I'm going to do a little bit of 3D printable prototyping. It's pretty common thing to do when you're designing an enclosure that you might eventually have, a mold or something. Start with a 3D printed prototype and kind of get the design right, and then you can hand it off to molding, either a company or you can do it yourself. So anyway, this is kind of what I'm going to build today, and it's a little more kind of, it's not really my design aesthetic typically. If for folks that have watched my streams before, I usually design things with nice soft curves and things like that, and they may still make their way into it, but given the use case, I went with something a little more cyber, if you will. This is, so it's got a lot of hard angles and kind of more industrial feeling. So that's what we're up to today. We're gonna design this. We'll design this in Fusion 360. So without further ado, now that we know what I'm going to be building, let's get it started. So I'm gonna start by taking a screenshot of this, just so I have it. All right. So there's my screenshot. Drag it off to the side for now, and there's my design. I'm gonna drag it down just so I can grab them. So I'm gonna switch over to Fusion 360. Okay, so I haven't done anything yet here, but let's get started. So I'm gonna do something a little bit different today in Fusion 360. Usually I start on the bottom, when I'm doing enclosure design, I start with the bottom part of the enclosure. But today I'm actually going to start by drawing the PCB, and then I'm going to go from there. And you can actually export the 3D file from EasyEDA and import that into Fusion 360, but I've tried that before and it just kind of makes a mess. It doesn't really work super well. So I'm just gonna go ahead and start. I'm just gonna draw it enough in here that I can build an enclosure around it. So start with new component, and that's the first thing that we always have to do because Fusion 360 is really very component based, and if you don't create a component if you're doing a multi-component drawing, you wind up with just a mess and a nightmare later on. So here we go. Let's start with call this GPS PCB. Boop. Okay, now we're in this component. We're editing it. Gonna start a sketch just right here, and I'm gonna go in and I'm gonna set up some variables So we're gonna say board, so PCB width, and that is 100, and PCB height, which is 70, and then we need these bolt inset bits, so they're 5 divided by 2, 2.5 millimeters in. So PCB bolt inset is going to be 2.5 millimeters in. Okay, so that is. Oh, and then we want to. I'm going to do something which is kind of wonky. I'm going to do print shrinkage %. And I want to do this because when you 3D print, for whatever reason, the print tends to shrink up a little bit, and then your bolt holes don't align to the bolt holes on the PCB, and that's kind of annoying. And I'm not really sure how much it shrinks, but I'm gonna start with 1%, because I think that it's 1 to 2 millimeters per like 100 millimeters. And in this case, because our board is exactly 100 millimeters, it'll be pretty easy to calculate that once I have a board, of course, but also once I print this, then I can measure it, and then I'll find out what the actual percentage is. I don't have these boards yet. I won't have them until next week, but and then I think there's probably some vertical shrinkage, but we'll deal with that later. That tends to not matter because you're not, the bolts are XY. So here we go, print shrinkage. Okay, so let's start our circle, our PCB center point at 0, 0, and we're gonna say PCB height. This is actually height. I want to fix some of this. This is PCB. We'll call this Y. PCB Y size. PCB X size, and then we also need a PCB height, or Z size. And that is 1.6 millimeters. Okay. All right, so let's go back in here, make a center rectangle, and we're going to do PCB Y size plus PCB Y size times PCB, or times shrinkage. Okay, so 70, it's not quite right? Let's see, let's go back to EZEDA. So it is, what is our 75 is our Y size. So I need to actually fix some things here, change parameters. So PCB Y size is 5. And then, and this is not a millimeter. This is, let's see. Let's modify, change parameters. Let's get rid of this and try it again. PCB shrinkage %. And no units on it. 0.01 for 1%. Okay, and let's see what happens. So this is PCB Y size plus PCB Y size times shrinkage %. Okay, 75.75. There we go. That's good. And we need actually the other constraint, which is going to be PCB X size plus PCB X size times shrinkage. Okay, there we go. And now we're going to put our bolt holes in. So I'm just going to stick it someplace. And we're going to put, that's going to be an inset. Boop. And same thing here. Inset. Inset. Okay. And now we'll put some more holes. Boop. Boop. And now we're going to constrain them. So I'm going to say this is constrained to this across this line. Oh, I don't have lines. So I need to do some construction lines from the midpoint. Boop. And midpoint. Perp. Cool. Now we can constrain this to this across this line. We can constrain this to this across this line. We can constrain this to this across that line. Okay, cool. We got the bolt holes. And I really want to change my preference so that when I right click, it just goes straight to cancel. Okay, so bolts are in there. Now let's get our let's get our display and our battery. So let's go over to Easy EDA and let's make some annotation. So from here to here, what is that? You know what? Let's do something a little bit different. Let's go find the source to this. Footprint. Let's copy that. Library. Footprint. Yep, that's the one. Okay, perfect. So if this is 0 and this is, so we need the X 2400. Oh, it's in mils. It's interesting. I wonder, let's go to millimeters. Okay, so here we're back to this. So X 60.96 is the X. Let's go to Fusion and make some parameters. Make screen X size 60.96. I'm just going to do 61 because that's close enough. And figure out this is Y is minus 39.37. So make another one. Screen Y size 39.37. So I'm just going to round that up to a half. Okay, so there's our screen, and that's our screen PCB size. So I'm going to call that PCB X size and then PCB X size. And now we actually need the screen size, and we need the offsets here, because notice that the screen is actually offset to the right a bit. So let's So this is the display area on this screen. So if I show you, here's the screen, you see that the display area is less than the host PCB. And I have to pause for 1 second because I think I have a delivery person here or something. So 1 second. Okay, I'm back. It was FedEx. They are delivering a generator because I'm on a well, and every time our power goes out, which is a lot because I live in the mountains, we don't have any water. Okay, so back to this. So the screen size, 48565, is the width. Screen X size, 48565. I wonder if that's really true. I wonder if this is I'm curious if it was designed in imperial or if it was actually designed in metric. So I'm going to measure it with my handy dandy digital coppers. And it's not actually clear where the screen starts and where the screen ends to me, but it looks like it's actually 25.3 in height. What does this say? Height 23.724. That's interesting because it's definitely wider than that. 25.3. Kind of hard to say where it starts, but I'm gonna call it 25.5. I'm gonna call the Y 25.5, and let's see, the X is maybe, looks like 49.5. I think it's supposed to be 50, but I can see part of it's cropped. 25.5, 45, 49.5. Oops, 20. All right, screen X size. We're gonna call this 49.5, and screen Y size 25.5. And now I kind of actually want to take a look at the PCB size. I'm sure they designed it in. I'm sure Adafruit designed the actual PCB size in mils, which is super annoying. In metric, so our designs, we have gone 100% metric. 39.3 tall and 61. It's almost exactly 61 millimeters. 61.1 wide. So what did we have here? Screen PCB 61, and I said 39.5. Perfect. So that's good. Okay, now we have to figure out the offset of this silly screen. And I think what I'm going to do is I'm going to set the offset in the top left corner. So we'll do screen X offset. And if we go to EZDA. So according to this, the offset is 8.763. Let's just make sure that I'm looking at this right. .765. So yeah, 8.763. So that appears to be right. So 8.7. I wonder if it's. I'm gonna see if I can measure here and get something similar. 8.4. I'm getting 8.5 actually, which is interesting. So we're gonna call it 8.5. And now the Y offset is going to be .5. Screen Y offset. And it's super important when you're doing these models to be diligent about using variables, about using parameters, because later on, as you change things, like if I change the PCB size or something, then I can just change the parameter, the variable. So it makes things a lot easier. Or if I need to adjust, etc. 8.675309. I love it. 8675309. Okay. You got it. All right. So we've got the offset from here. And now if I look at my design, it's centered Y, and it's not centered X. So I'm gonna make, this is a little overkill probably, but I'm gonna make variables for the offset on this as well, where it's placed in the board, just so if I need to move this screen around later, it becomes easier to do. But I'm going to do, since I'm placing this screen relative to the center of the PCB, I'm actually going to measure the offset from the center. So we're going to do screen PCB offset. What should we name this? Because this is actually the center offset. So screen center X offset. And this is 0 because on the X and Y it's going to be offset by 0. So it's going to be directly in the center. And here, so center to center of this screen is going to be a little tricky. So I think we're going to do, let me get rid of some stuff. Okay, just document. So we're going to go from here to here. Boo, 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 boo. Come on. 8.425. So now we got to do a little math. So if the screen PCB size is okay, so total size is 39.5, and then minus whatever that offset was, 8.425, 8.425, and then I think we need to do divided by 2, right? Does that look right? Does that look like the right mathematical formula? So 39 minus 8.425 divided by 2 equals, I really should have put that in Calca. All right, so 39.5 minus 8.425 divided by 2 is 35,287. Actually, I'm overcomplicating this, aren't I? Wait, no, because I have to get it from the center. So it is a 35, it's minus 35,287.5 offset, I think. So does that make sense? If we go here and the screen PCB, the whole thing is 39.5. That doesn't make sense. We're 4 millimeters away from the whole size. Okay, so that's not right. So it's 39.5 divided by 2 minus 8, right? Because that's the size of the screen. Get it halfway, and then minus what our measurement was. That makes a little more sense. 39.5 divided by 2 minus 8.425 equals 11,325. Okay, I think that's right. So screen center Y offset. Screen center Y offset is minus 11. Copy 11,325. Did I? Yep. Minus 11,325. Okay, I think that's right. Oh, I think it's right. Okay, let's draw another circle. Sorry, a rectangle. And I want to do center, but I need the center just somewhere. I don't need it to not do, and I want it to not be that. I want not construction line. So let's try it again. Center, and this is going to be screen PCB Y size, screen PCB X size. Okay, now we need to constrain it. So from here to here is going to be the screen center X offset, which is 0. I'm hitting enter, nothing's happening. Why is it not liking that? Screen center F offset. No, what if I just put in 0? What happens? It literally won't let me do that. Okay. What about the next one? Oh, because I can't. I think I know why. This is pretty silly. So it won't let you position it from this. It would have to be positioned from these, which is kind of dumb considering that I drew a center point rectangle, right? So maybe we just get rid of that and let's do this the long, complicated way, a 2-point rectangle. Okay, so whoop, and we're gonna do screen PCB Y, screen PCB X. Okay, this is gonna get some pretty silly math here. This is gonna tax me. Okay, let's start with the easy one. So this is going to be screen X size, screen X size divided by 2, and then plus the screen offset, screen X center offset, right? Oop, that didn't work. Screen, did I get this right? Screen X size divided by 2 plus, yeah, that should be right? Because if it's 61, let's see what happens if I just do that. 24.75. What is happening? So screen PCB. Oh, because I did the screen X rather than screen PCB. So this is screen PCB X size divided by 2, and then plus screen center X offset. Okay, there we go. And now, moment of truth to see if I did all this right. Screen PCB Y size divided by 2 plus screen Y offset. Look at that. Is that right? 8.425. Let's go back to this and just double check. 8.425. Look at that. I'm impressed with myself. All right. Jeez. Okay, now we have the screen PCB. We should probably save this. GPS sensor tracker enclosure. Now let's do the internal, the actual display area. Maybe I should rename these variables a little bit. So this is screen display area, X size, screen display area. I'm gonna be a little verbose here. Screen display X offset area, X offset, screen display area, Y offset. Okay, we're cruising. Make a thing. This is going to be screen display area, Y size, display area X size. Boop. Okay, sweet. Now we need to offset these from here. Oops. Nope. Stop that. Screen display area Y offset. Boop. That looks right. Screen display area X offset. Hey, all right, that looks pretty good, right? That looks like we know what we're doing. Save. Now let's get the battery in there. All right, we've got all kinds of shit we drew in here, huh? What is that? Oh, that's the GPS. Okay, our battery. We have to do this all over again, huh? Oh. Battery holder. So that's a 1043p. Okay, and the battery is 77 by 20.65. I'm gonna write that down here. 77 by 20.65. You won't be able to see that, but trust that it's right there. Fusion. some parameters. Battery holder X size was 77. Battery holder Y size 20.65. All right, and now I'm going to measure the height of it, and that I'm going to measure the height including the battery. So we'll just pretend like it's all in one. So that looks like it is 18.2, call it 18.5 to give it some space. Battery holder Z size 18.5. Okay. And now we're going to do the offsets again. So make another one of these. Let's make this window bigger. I really one of the things that I don't like about Fusion is like a real bug. I think it's a critical bug. Is that you put all these parameters in here that you build your model from, which works great in this document, but if you ever import a component, it winds up in this model parameter, and it like all of the names, you can see all of these names are gone. So you lose all these nice naming here. Anyway, okay, so battery holder Y X offset. Is it center? And center X. Center X offset is 0. And now we need to figure out the Y offset. So if we go in here and we let's draw a line. Luckily this is centered right on this right on a millimeter grid. So the offset to this from here to here, 25.5. Very good. Super easy. Perfect. Okay. Great. Now let's draw this battery holder up in here. Battery holder Y size. Battery holder X size. And then from here to here is going to be battery holder X size divided by 2 plus offset, center X offset. And then from here to here is going to be battery holder Y size divided by 2 plus battery holder center Y offset. And that went sideways. I think I need to minus the offset because I did it from the bottom. Weird. If I put it in a minus, it won't work, and it doesn't give me any kind of error as to why. All right. Let's Holy. Well, that was sucked. What is this? Did I grab the wrong way? remove. I just want Autodesk Fusion 360. Boy, you know we're doing well when we're pushing it to the limit when we're crashing it. Fusion takes a long time to load up. Doop doop doop. Is it loading though? Does it not even want to load anymore? Autodesk Fusion 360. All right, it's loading. And loading, and loading, and loading. Should we watch some waterfall while that loads? All right, it's loaded. Maybe. Boop, boo, do 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 do. Okay. Let's see how much we lost. Oh, we didn't lose that much. Something doesn't look right though, right? Where's my origin and grid and all that stuff? Weird. Okay. Let's go back to the battery making. Usually it gives me an auto save, but we crashed it so hard it didn't even auto save, I guess. Okay, battery. Battery holder. X size 77. Battery holder Y size. Oh, are you kidding me? What is happening? Like repeated Fusion 360 crashes. Starting to get a little absurd. Okay, let's try to do this again. Fusion 360. You're loading. Should we go back to waterfall? And waterfall. Look at that. That's nice. What is this nonsense? Okay, Fusion. I have trepidation. Let's see if we can try this again. Battery holder, X size 77. Battery holder Y size 26.5. Okay. And battery holder Z size. I don't remember what this was, so I've got to measure it again. $18.5. Okay, and let's save this. Let's try this again. What is happening? Let's see if there's an update. Yeah. Fusion 360. See, how do we... Is it like a check for update or something? Uh, 2.014109. Up in here, preferences. Okay. Is there an update? Tooltips, general, preview features. I don't want to name that on. Okay. I don't actually see anything in here about that. I wonder if I need to All right, let's see. Autodesk Fusion 360 Mac M1 keeps crashing. Crashes on launch. That's not what I need. Product compatibility. Let's see if we've got some, if there's some notes. What is this? Absoft Neat video. I don't know what this page is. Don't see anything super helpful in there. How do I find out what the latest version is? I think it actually updated. It said it updated, but then it's been crashing since. Sigh. Well, should we just try it again? See if it stays alive. Staying alive, staying alive. Okay, are all our battery holder sizes in there? Yes. Oh, all right, one more time. Battery holder, Y size, battery holder, X size, 26.5, 20.65. That's why that doesn't look right. 28.65. Okay. Let's constrain this. Battery holder X size divided by 2 plus battery holder. Battery, where's my offset? Oh, I don't have it. Modify, change parameters, battery holder X, battery holder center X, offset, it's gonna be 0. And let's go back to 25.5 is Y. So 0, 25.5. Okay, let's go back to this. Plus battery holder center X offset. Sweet. Save because we're crashing. Because we're crashing a lot. And from here to here, it's going to be battery holder Y size divided by 2 plus battery holder Y offset. Right? There we go. Save again. That looks about right. Let's just go to our this. Okay. It looks good, right? Looks like it's correct. Okay. So now, next things that we need to put on here are the other things that affect the enclosure design. So our antenna, our solar power bit, and our USB-C. So let's go back over here. And looks like the USB is 17 in, solar's 10, and then we'll measure that in a sec. So modify, change parameters. USB X offset, USB X, and it's a center offset, not a center X. If that's not confusing. 17? Yeah, 17. Okay, and then we need our solar input. USB, so solar input X center offset. And this is going to come in from the right, and that was what, 8? 10. Okay. All right. So now we need some sizes for that. So USB-C. Oh, I don't even know if I have a USB-C here to measure. Oh, it looks like I do. From our Core Compute dev module, looks like that is 9 millimeters by 3.4 ish. 3.2. 3.2. 9 by 3.2. So let me take some notes here. So USB is 9 millimeters wide, 3.2 high, and then the depth is, well, we don't care about the depth. I just need to know about the opening. and we're gonna do. We actually do need a Z center offset, so we need to know how high it is on the off of the board, and I don't have. Let's see if I have a board here that has some of that. All right, I do have something. So this is actually how it. That's the actual core compute module that sits on the board that has the USB breakout. So it would be 1.6 would be PCB height, and then it would be sitting on top of that. So actually we don't need to measure that. We just need to know that it's off of the PCB height. Hey Trey, good afternoon over there. Good morning here. Today we are watching Fusion 360 crash. That's really what we've been doing. Okay, so let's make some construction lines to help us out here. From here, perp up, and we're gonna do the USB center offset. So that's gonna be where the USB center is. And then we're gonna do a line here to perpendicular, and this is gonna have the solar center offset. Cool. And then we're going to I guess I do need the depth on that USB because I want to draw it. So 7.33, call it 7.4. 7.4 deep. All right. And we need to save this because, as we've seen, it's been liking to crash a lot. USB USB jack, and it's X size, so it's 9 millimeters wide. USB jack, Z size was 3.2, and USB jack Y size, so 7.4 deep. And it's going to be offset in the Z direction, but we can figure that out later. Right now I'm just going to draw a triangle, draw a rectangle. I don't want a construction, I want a real box. This is going to be USB jack X and USB jack Y. Okay, and now we're going to do it's actually just flush. It's flush with this, so I'm going to, in case we need to change this later, I'm going to constrain it with a dimension and just put dimension of 0. Oh yeah, why will it not let me do that? I could do coincident. I don't love that because if I have to change that later, having a constraint like that is kind of a pain. Doesn't like me to do that anyway. Okay, well, maybe it's this one. I think it's coincident, but it just won't let me do it. All right, so what if I did this? This is kind of goofy. What if I did this one to this one, and then I said USB jack Y size. There we go. Dumb. That was kind of silly, right? I think that felt like a bug, Fusion bug. And let's save, and let's go back to EasyEDA just to kind of, yep, and that looks about right. This is interesting. I wonder if we're gonna have, so we'll put this up above, I guess, all of this. We'll put the screen kind of high above all the stuff underneath. So we'll put probably a fat header. I wonder how many holes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, that's a weird number. So I have a 14-pin header, right, for our Meadow stuff. So I'm gonna have to cut one of those off, and then I'm gonna put it. I'll put it like so on it, on the header on top of that, so that will give lots of clearance underneath. Okay, now let's get to the solar jack. We're gonna do the same thing. Silliness, 3-point, boop, and we're gonna do solar input. Do we not have any, did I not do the sizes on that yet? I guess I didn't. So let me measure that. It is 5.55. I wonder if it's really 5.5. 5.55. No, it's pretty consistently 5. No. 5.49. 5.51. 5. Okay, so we're gonna call that 5.5. Solar jack 5.5. We'll just say that's the X. The Y is gonna be 12, and the height is 7.5. All right, modify, change parameters, solar input. Let's call it, yeah, solar input. I'm having a hard time typing. Solar input. X size was 5.5. Solar input Y size 12, and so solar input Z size is 7.5. Z size 7.5. And save, because we've seen how crashy Fusion has been today. Solar input Y size, solar input X size, and then constrain from here to here is going to be solar input Y size. And actually, that's not right, because in this design, it hangs off by 3 millimeters. So go to properties, solar input, should call that dangle size. I don't want to do an offset because it's not really from the center. It's the overhang. That's what it is. Overhang. Solar overhang. Edge overhang of 3 millimeters. Okay, so this is going to be minus overhang, right? There we go. Cool. All right, we're so close to having the basic PCB layout. And we're so far away from having a complete enclosure. But you know, this stuff takes time. Okay, so this is my antenna. And on this one, I just want to know the center offset. So center offset's 4 millimeters. Antenna, PCB center offset, and it's going to be -4 because it's going to go down. And I'm just looking at the antenna here, thinking about how I want to. I think I'm going to draw that maybe later. We'll have a line though for now. So that's where the antenna is going to go. Cool. All right, let's start. Now that we've got kind of where everything is, we're going to start making this 3D. So here it is, kind of drawn out. And we're going to take the whole thing and we're going to PCB height. What's our PCB height? Do we not have a PCB height? Whoops, 1.6. Oh, look at that. We missed a little piece too. So let's get back to this. Modify. Parameters. Oh, we did. PCB Z size. Boop, boop. Okay. PCB Z size. Great. So there's our PCB. And now we're actually going to do another sketch on top here. Why did it rotate like that? That's silly. Oops. Okay, now we're going to project some stuff in. Project. I want to project our, not our USB yet, but solar is straight on it. So we're going to project our solar, and battery is on it, on this plane, right? And because USB is above, because it's on its own little module. So we project those in and finish. And now we're gonna do a little something tricky here because I want this, well, let's project the solar real fast. So we'll do, we finished our sketch, right? Why are we not? It's gonna be solar Z size. Boop. Okay, there's our solar input jack. Whew. Okay, now we need to project our battery up. So let's press pull. Where's our, what the heck? Oh man, I see what happened. Okay, we got to back up a bit because we wound up with a sketch outside. It was on this GPS out on the thing here, which is kind of silly. So it was on the wrong component. So we got to go back. Okay, so we got to go back to this, the PCB, and now we're going to put a sketch on top of it and show our underlying sketch and project some stuff, battery and solar. Okay, finish sketch. That's weird. Weird. 3D mouse time. So project our battery up. Battery holder Z size. Boop. Okay. And wait, why is this body outside of the... Okay, we have to go back until this body's gone, because when we pulled, when we extruded this, it extruded it on the main drawing. We have to go back here. Okay, here we go. We're on the thing. Press pull. That little thing. Okay. Extrude PCBZ size. All right, stay on this. Create a sketch on this. Show our underlying sketches. Project up our solar and our battery holder. Finish projecting. I missed a line here. I need to project that. Okay. Finish the sketch. And now press pull that. Battery holder Z size. Boop. Q. Press pull this. Solar Z size. Okay. Cool. Now we need to do a little, we're going to do a fillet or a chamfer on top of this battery thing to give it some space. So battery, I'm going to do this. I'm going to do fillet. We're going to fillet that. Let's see if it's going to do the right, if that's going to do the right thing. No. We need to fillet, we need to put a round thing on top here. Let's say, and it's going to be the battery holder Y size. I think I'm doing it wrong because you need a corner. So I know what I'll do. I'll do this one. Battery holder Y size divided by 2. Boom. And then we'll do this one. Battery holder Y size divided by 2. Okay, good enough. So that gives us the area clearance for the battery. And we better save. Although, I will say, it's been like 5-10 minutes since Fusion crashed. That's pretty good, right? Okay, now we're gonna go back to this sketch here. We're gonna project some other stuff. I'm gonna project the PCB on the, actually I want to do an offset plane for that. And I need to do an offset plane for this USB as well. So let's do, we're going to construct an offset plane, and it's going to be from this sketch and it's going to be PCB Z size. Okay, good. And now I'm going to make a sketch on top of that, and then I'm going to project this USB. Boop. Say okay, finish sketch, and now I'm going to put that up, and that's going to be the PCB Z size. Sweet. So that's kind of floating. Recall there's a PCB underneath the USB, but I just need it here so I can project it, because we're going to project the opening through the wall. So it can be floating. That's good. That's fine. Floating USB. And now I need to figure out my screen. Where the screen is going to be offset from the top of the PCB. So I'm basically going to have it like this, right? It's going to be on a header down. So I'm going to measure all this height stuff. It's going to be 11 millimeter offset. Screen Z offset. Did I say 11? I think I said 11 millimeter. And then that's going to be, so we construct a plane from here, and it's going to be screen Z offset. Boop, sweet. And now we're going to draw a sketch on here, and we're going to project in the screen's PCB. Okay. And now we're going to extrude that, and that's going to be PCB-Z. I think they used a 1.6 on this. Oh. .6. Sweet. Cool. And now we need to find the screen thickness, which is kind of funky. It's not actually on there very straight, but we're gonna get it. We're just gonna. So 2.9 between the bottom of the PCB and the top of the screen there. Let's see. I think it's actually 2.9. Okay, so 2.9 minus 1.6 is 1.3. So modify, change parameters, screen display Z size 1.3. So now we're going to do a sketch on top of this. We're going to project in our screen. Actually, this is interesting because I probably want to project in the whole. So I've got screen area size, and then I've got actual screen size. So I think what I want to do is go back to this original sketch here and then add in, I want to add in our screen size, not just screen area. So modify parameters, because we got screen display area, and we need just screen size. So screen size, screen X size is going to be 29.2 ish, 29.2. Actually, that's Y size. Y size 29.2. and then screen X size. And we're just going to call that the same. Actually, instead of doing that, I'm going to do, it basically runs from right to left on the PCB, so we'll just use the PCB size. Okay, so let's do a, did we just center that before? We must have. It's like screen center Y offset. I wonder if it was actually, I think it's just centered. Was there any offset in there? I think it's really just centered. So I might have made that a little more complicated than I needed to. Minus 11,325. Yeah, I think it's really just centered in the middle. Okay, so let's draw a rectangle, and we're going to place first corner there, and it's going to be screen Y size, and this is going to be screen PCB X size. And now I'm going to center that. So we're going to do the same. So this is going to be, this is silly, screen PCB Y size minus screen Y size divided by 2, right? That should center it. Yeah. That's centered. So now I think I should fix this. And this should actually be, actually this one. This should be screen. I'm going to center it. So maybe what I should do is draw a center line. We'll here. Screen PCB Y size minus screen display area Y size divided by 2. That should just center everything. Good. Perfect. Okay, finish sketch. So now I'm going to make a sketch on top of this, and I'm going to project in some stuff. I'm going to project in this. And hit OK, finish sketch, and now let's extrude that. It's going to be the screen display Z size. Cool, so now we've got our display in there, and then the final thing here is I'm just going to project in the area of the screen, the stuff that we can see, because we're going to design to, what's happening? Oh, I forgot to hit project. Cool. So we're going to design to that area, right? Okay, and we got everything except for our antenna, which I'm going to handle later. So this is good. We're making progress. We're an hour and a half in, and we basically have the PCB good enough that we can design around. The last thing I need to do is bolts, so the bolt holes. So I'm going to go back to which sketch is it? It's this sketch is at the top. Go back to this sketch, and I'm going to project our bolt holes. Boop, 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 boop. Okay, finish sketch. And now let's drill some holes. That one, that one, and that one. And I guess we need some parameters. It's going to be PC bolt hole, PC bolt hole diameter 2.1. So let's go edit this again, and this is going to be PCB bolt hole diameter, and it's going to be a flat. It's simple, flat, and this is going to be all. There we go. Cool. So now we got those bolt holes in, right? Looking good, looking good. There's our. That's going to be basically our PCB. Not bad. So now we can start in on some enclosure. Save, and we'll do quick break time. Okay, I'm back. Hopefully everyone can hear me. I haven't lost my audio. So we got the PCB in. Now it is time for some oh, where's my projection? That's weird. Oh, I see why, because the whole thing's. Okay, so now it's time to do some enclosure. Enclosure time. So we need a new component. Call this GPS enclosure bottom. Okay. And we need to make sure that's all this stuff still visible. What? That's some weird stuff in there, huh? Like that's a weird rendering? Huh. Very interesting. Well, whatever. Okay, so we need some more parameters because we don't have enough. We're going to do enclosure wall thickness, and I'm going to start with 2 millimeters. And so the bottom is going to be kind of a big open area, and we will I'll probably print the lid going kind of right here. So let's get started on the bottom. So first we need a sketch, and we need, okay, so we're selected on the component, and do a sketch here. We're looking at the bottom up. So I'm gonna need to project some stuff. I'm gonna project, and I don't want these bolt holes. I actually want this. Ah, that's weird. What is that? Well, we'll project those original things. Okay, so finish our projection, and now I want to so we're gonna have some bolt mounts, and it's gonna sit kind of maybe flush. Should it sit flush on the bottom of this enclosure, or should we have some clearance? I feel like maybe we want just a little bit of clearance, just so it sits above just a little bit, just so we have, because we have through hole things on there on the bottom of the PCB, so we will need clearance. So what's the through hole poke through? It's like a couple millimeters, I think. Does this thing keep going to inches? So we'll say 2 millimeters. PCB Z, PCB bottom Z, clearance 2. Okay. So finish that, and what we actually need to do is, I should have just done an offset from that, I think, in the beginning. But we're gonna do it now. Offset it from here. PCB Z is it off? What was it called? Clearance. Offset. Clearance. PCB bottom Z clearance. Boop. Okay. Did it create our? There it is. There's our construction thing. So now I want to sketch on top on this, and I want to look top down. So I'm going to do turn that off. I'm going to turn this off, and I'm going to do a sketch right here. Cool. And boop. Turn this sketch on. Okay, now let's project some stuff. I kind of actually want to go back. I want to get rid of this sketch. Let's just go back and get, because it's going to confuse me. So okay. So here we have it. I know we're going to do an offset sketch, or an offset construction plane. So I got to re-add this. PCB Z, PCB bottom Z clearance, 2 millimeters. Okay, so we're selected on this component. Let's do construct an offset plane to the bottom of this, and it's going to be PCB bottom Z clearance. There we go. And then we're going to do a sketch, and I want to look down on it. So let's get rid of that out of view. Okay, here we got our sketch. And now we're going to turn the visibility on this and get our first sketch clear. Okay, and now we can project some stuff. We want the bolt holes and the PCB. Okay, sweet. Now let's turn that off. Okay, so that's where the PCB is going to sit. And we need some internal clearance on the sides. So let's make another parameter. PCB, we'll call this, maybe we should make a uniform. I think I'll start with a uniform clearance right now. So we'll say PCB, what do we call that? Is it horizontal clearance? Horizontal clearance. And we'll make 1 millimeter all the way around. So now I'm going to offset this, 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 and this, and it's going to be the PCB horizontal clearance. Cool. So bolt holes, PCB, beginning of our enclosure. So let's offset again for these walls, and this is going to be, oh, already been offset. It's another stupid Fusion thing. You can't offset something that's already been offset. Oh, frustrate. Okay, but we can re-offset this. We just have to add the clearance. It's stupid. So clearance, horizontal clearance plus wall thickness. Boop. Okay, cool. So we have some basic enclosure stuff here. So now we're gonna extrude the whole thing. It's gonna be thickness, wall thickness 2. And now we're going to I'm gonna extrude. We got to put the bolt. We got to put the bolt mounts in, and we've got to do the walls on the bottom. And when we do this, the wall on the bottom, we're gonna bring it up to some point on the rest of the PCB. And for the ease of printing, I want the lid bottom to be flat. So I'm going to bring it all the way up to the top of this. So if we do, so this should be easy. So we're going to do extrude this wall, and we're going to extrude to object, and it's going to go to the top of that. Boop. Look at that. So looking good. Looking good. Let's see the whole thing so far. Okay. Now, I'm just thinking ahead a little bit, because I've run into this problem before where I've got we've got the bolt holes where the PCB mounts, and that's fine. And then the PCB, when you put it in, it's just going to drop down in. But then we need to do lid bolts so the lid can bolt on. And the problem is if I put them in like here, then you can't get the PCB right? Because you need a place for the bolts to sit. So it has to be in a heat set insert. And if I put them inside here, I can't drop the PCB down. So I actually need to put the bolts, kind of the lid bolts, outside. So what I might do is make some external things where the bolts, where the heat set inserts go into, and bolt down that way. And that'll actually look pretty cool. So I don't have my, let me grab my, let me show you, I want to draw what I'm thinking of. Let me go grab my iPad and see if I can get the QuickTime to show it. One sec. Okay, I'm back. All right, let's see if I can get this. Last time I couldn't get this to show up on my QuickTime screen viewer, but we'll see. See if it can work this time. QuickTime player. File new. Movie recording from iPad. Okay, there we go. So what I was saying that we could do there, so this will be a real quick sketch, is here is our this is our enclosure, right? Looking like so. What I think I can do is build these kind of external things here, like so, and so then the lid will mount. Am I frozen? my webcam going crazy. Anyway, so the lid will mount like that. So enough of this. Maybe. All right. Is my webcam acting up? I think it might be. Let's see. Yes, it is definitely acting up. All right, well, you'll have to deal with 1 frame per 5 second webcam stuff. Okay, so that's going to be the bolts. Let's make the mounts for the heat set inserts in the bottom of the enclosure. So let's hide that. Let's go back to editing this component, and let's go back to this sketch here. And what I want to do is I can just make a couple of round like cylinders and extrude them up over this. The other thing I can do is maybe make a triangle of some sort from the corners. But I think, and what I'm saying is I could do something like where I put a triangle in, you know, like that, and then lift that up. So maybe I'll do that. Let's make let's do that. Let's make some construction lines from here to here, and from here to here, and constrain them. And I'm just going to put in a number, and we'll do this constrain from here to here, and we'll do the same constraint as that. Okay, now I guess it has to be bigger, huh? Because if we draw a line from here to here, it's not gonna get that. There's not gonna be enough material for that bolt. So this is not a construction line. So let's see, maybe 12. Oh, looks pretty good. Do we like this, or do we want just cylinders there? I think it's fine. I don't think it matters. Cylinder may be cleaner. Yeah, let's do cylinders. Let's go back to the sketch. We'll get rid of this. Boop, boop, boop. And let's draw a center diameter circle. And let's go tangent to that. Boop. That's not bad, right? And then maybe we can make some, maybe we can clean it up like this. What's happening? That'll be cool. That looks, I think that's better than the triangles. We're constraining it to the quadrant. It's kind of an automatic constraint when you go from center to quadrant. Okay, so we got that. That's looking good. Now we need to, we're going to extrude these sections. And that's a lot of selection. I almost think I should make a new sketch for those, and then I don't have to do all the crazy selections in there. What is that? No. What did it just select? I don't know. Alright. One more to go. I'm not a great 3D mouse user. Okay, and then we got a couple options. We can extrude them up to the bottom of the PCB, but I think it's just going to be easier to do clearance. Bottom Z clearance. Boop. All right, so there they are. They're extruded up. And now we need the holes for the heat set inserts. So let's make a sketch again. On top of that. I need to get on top of that. I need to select the top of this. It doesn't want to select. Okay. Let's try this again. Sketch, There we go, on top of that. I had to turn off the other sketch. And we're gonna project in these center points. Boop. Finish sketch, and now let's get some holes in there. And somewhere here I've saved my settings for the bolt holes. Let's see. Oh, here it is. M2 taper, M2 ping. Okay, so this is the hole that I need for the M2 heat set inserts. This is the, oh, that's the bolt though. That's not what I want. I think I need the taper. Oh, so that's the tapering for it. So I guess I do need the M2. So bolt, hole, simple, 4.5 deep, it doesn't matter how deep. So 3.4, and it's weird because it shouldn't be like that. 1.9, well, we'll play with it in a sec. So I need to create some bolt holes. Whoa, that's weird. Or some holes, one there, one here, one here, and one here. Okay, so I think this needs to be it needs to be 3.4. 3.4 wide. That looks about right. And the distance is going to be 3 millimeters. I think they need to be 3 millimeters deep. And those are for those little heat set inserts. Okay, those are in. Sweet. And they don't go all the way to the bottom. Perfect. Okay, so that should mount our PCB. We should save this. Heat set insert. These are heat set inserts. So these are nice because you can put them in your, you use a soldering iron and you heat them up with soldering iron, and then you insert them that way, and then the screws go into them, the bolts go into them. All right, so looking pretty good. So we have, let's show our stuff, turn off that, turn on the bodies, and then select this so we can see the whole thing. All right, so we're making progress. So far, so good. That is our, so far that's our enclosure. So I want to make some holes for our USB and for our solar jack. So we're gonna go back to this, and I'm gonna make a sketch on this. And I am going to, I need to be able to see, I need to be able to, it's weird that I'm not able to see through this. So let me see, turn off the bodies. And I should, I wonder why I can't project that. I need to project this there. I need to project that, and I need to project the front of this. Okay, cool. So there's my sketch. Finish it. Go back to the body. Let's turn this off. Okay, so now we're gonna do, oh, and I wanna get some clearance on this as well. So let's make a parameter, and we'll say cutout clearance. And for now, we'll do 1 millimeter. Now let's go back to the sketch. And we're going to offset this. We'll call it cutout clearance. Boop. We're going to offset this one. Cutout clearance. Finish sketch. Cool. And now we're going to extrude. And it's going to go to object to this side, and it cuts, and everything's good. Sweet. Look at that. I kind of want to make a bit of a round. You know, the USB-C is round. I also, this is interesting. So on the solar input, it sticks through. So if we go back to EasyEA, you'll see that it sticks through. So I don't need much clearance. But on this USB, I actually need clearance for the cable, the USB cable that would go in there. And so what I'm gonna do is measure some USB cable, and so let's go back over to this and let's edit this this extrusion here, and let's get rid of this one. So we said okay, so we just have that, and now let's go to this sketch, and I'm gonna get rid of this offset, and I'm gonna draw a center rectangle actually, but first I want to get some parameters. So we'll do USB plug X size. So I was measuring a USB plug here on my, so 12, I think we'll call it, just give it some space, 14, and then USB, oh, this is C, USB-C plug Y size, and let's call it 10. Why isn't it like that? Doesn't like dashes? Really? USB-C plug Y size, USB-C plug X size. Okay. So let's do a center rectangle from center of this, which requires us to know the center. Oops, that didn't, I don't think that went, there we go. Okay, and now turn off construction, center rectangle, boop. It's gonna be USB-Y, USB-C plug Y size, USB-C plug X size. Cool. All right, so that gives us our pluggy hole. So let's extrude that, and it's gonna go to object this side, cut, boop, boop. All right, nice. Nice, nice, nice. So there's our USB-C, solar, making progress. If I can fix my webcam. Let's save this so in case it crashes. Boop. Studio display, camera. Okay. Nope. probably have to restart OBS or restart something. So this looks pretty good. And just so we can keep on task here. So this was kind of our original design. So we need our external mounting bolt holes, which we are going to pull off on the side as we talked about. And then we need a lid. We need a lid. So I think I'll do the external bolt mounts last. And I also need the antenna hole, which we'll do later as well. So let's start in on the lid. And this will be kind of interesting because we need to do clearance for this, for the battery thing. So far so good though, you know, like we actually have something. Okay. So we need a new component, and this is gonna be, name this GPS enclosure top. By the way, instead of just calling this top, I call it, you know, like GPS enclosure. And the reason why is when I go to export this component as an STL for printing, it grabs the name of the component. So if I am a little bit more specific here, then it winds up as something that makes more sense later. Okay, GPS enclosure top. So now we need to, we need a sketch. I'm gonna start with this. And I want to need to project some stuff in. So I need to project in the battery. Okay. And let's see, I should already have, yeah, so it's because I created it off of that, the enclosure, I already have the wall stuff. But I'm going to project in this anyway, just so it's more clear. Okay. So there is my thing. And now I need to do the area for the battery, because recall we're going to do kind of like a raised area of clearance. So let's put a construction line here to here, and we're going to do a driven measurement. And what that means is that you can't edit this. And then I'm going to do this to here, and I'm going to base it off of that driven one. There we go. So, finish sketch. I'm thinking through how I want to construct this. I think I want to project in some wall stuff. Yeah. Okay, so I don't know why it keeps doing that. So we're going to project in this, and this. Okay. Finish sketch. And now I'm going to extrude. Oh, I guess that needs to not be a construction line. Okay, let's do this. Edit this sketch. Edit this sketch. This is going to be a non-construction line. Okay, now we can, let's extrude the lid up a bit. I'm going to call this thickness, enclosure wall thickness. Okay. Okay. So far, so good. We have lid-ish. Lidish. That's like it's the Pokemon version, Lidish. And now, let's go back to our inspiration. So we're going to bring that up, kind of a box, and then maybe chamfer it. Chamfer. All right, let's make a sketch on here. And let's project. Need to project. No, I don't need to project. I need to create a line. And this is going to be from here to here is going to be our enclosure width, wall thickness. Okay. So now we're going to extrude this up. So this is going to be tricky. So we need to make this to the top of the battery plus some clearance. So let's see, we got, I don't even know. So I'm going to do, I need to project something in. Let's do cancel. So I'm going to project this. I think I'm going to have to project this battery. Let's do a sketch over here. So let's do a sketch on here. And let's project in this. Okay. And then we're going to do a line, some construction lines. We'll do from here to there, and then project it to there. This is interesting. That one didn't. That one's unconstrained. That's why it's funky color. But what if we just do from here to here? That's still unconstrained. What if I do a line from here to there? So that's not unconstrained. All right, and let's save. We'll do battery. We need a new parameter, and we're gonna call this battery ceiling. Battery ceiling clearance. And we'll give it a couple of millimeters. Boop. And I'm going to not create a line. I'm going to escape. I'm going to offset this to minus battery ceiling clearance. Okay, good enough. So now we're going to extrude this wall and we're gonna to object this thing that I made here. Let's turn off these bodies. Turn off the whole thing there. I need to select, I want to select this. Boop, there. Okay. Let's get some clearance. Now I'll make a sketch on this. Boop. And let me see if I can just, so sketch is there. Let's extrude this up, and it's gonna be wall thickness. Hey, all right, okay. Look at that. That looks like an enclosure almost. Top off, top on. Okay. Looking pretty good. Looking pretty good. I'm going to do something here. I'm going to add some appearance, blue plastic. Blue plastic matte. Actually, let's do white plastic. White plastic. Plastic matte white. We're just gonna apply this to the enclosure. Boom. Okay. I just did that so I can, so I'll show you why. So now when I'm looking at this, it has a little bit of, oops. Yeah, that's the top. Why is that's not what I'm trying to do. There we go. So now I have just a little contrast between things. Boop, boop, boop. Is that a shadow? That was weird. We're seeing some weird rendering bugs, right? Okay, lid. We've got a lid. What do we need to do now? So now I want to start cleaning this up a bit. I want to start adding some angles, some fillets and stuff. But before that, I think I need to add my lid bolt bits, which means I kind of probably need to figure out where my antenna stuff is and put that in. Let me grab my antenna component. In my cool Work Electronic Lego box here. Lego kit. So this is my antenna bit. Okay. So let's go in and do some stuff. So first of all, my antenna hole diameter. It's my antenna 6.2. So antenna hole diameter is going to be like 8. Change parameters. Antenna hole diameter. Just put it 8. Should be plenty. I hope that this clears. I think it will. I think I'll have enough clearance. Wow, my webcam has really jumped the shark, hasn't it? I think this will have enough clearance to hang out of the enclosure pretty well, because it's got, I should have put this all the way to the edge, but I didn't. So that might have to be Rev 2 after we'll see. Might have enough. Yeah, it might be okay. Just looking, I'm comparing mine and the one on this GPS module that these Worth electric parts are just so nice. It's so crazy compared to like other stuff, just how much nicer they are compared to like the cheaper parts. Okay, my antenna stuff, we need to figure out, so we know where it's at, that's the X offset. I need to figure the height off the PCB, so I'm going to measure that. I'm going to throw it around a bit first for good measure. So looks like 5.5 exactly. That's interesting. Cool, 5.5. So we go back to Fusion, and it's going to be antenna. Antenna PCB, antenna Z, antenna PCB Z, offset, center offset, Z, center, PCB, center, Z offset, Z, center offset, 5.5. Okay, and then we got the bolt size, and or the whole diameter, and the center Z offset. Okay, so let's go in and let's make sure we're on our bottom. We're editing that, and let's make a sketch here, and then we're gonna do some projection. So we're going to turn off the top so we don't see that, and then I'm going to turn on the sketches for this, turn off the bodies, turn off here it is. So I need to project this line. Okay, perfect. So if I go here, okay, there it is. So now I need to, let's make a construction line from here up, and let's finish this sketch, and then let's, I actually want to jump back into it. Wait, we're not on the top, we're on the bottom, so let's collapse that. Okay, just because I wanted to get the, I wanted to get it not in 3D view, I just wanted a 2D on. So we're going to make a point on this line. Oops, not in the center. We're going to make a point somewhere on this line, and now we're going to constrain it to here. This is going to be the antenna center Z offset. And I'm actually not sure if I did that right. It might need to be center Z offset plus PCB height, because that's looks like it's the bottom of the PCB, right? So let's try this again. Center Z offset plus PCB height, PCB Z size. Okay, and now let's make a hole for it. Boop. What? Oh, okay, this is good. Not all, to this size, that side, and the diameter is going to be the antenna hole diameter. Great. Okay, cool. Now we got that antenna hole in there. Feeling good. Save. So now we can put our bolt holes. Now design-wise, kind of thinking about this, maybe we put our bolt right kind of in the center there, and then we do one mirrored right here. Our lid bolt mounts. But if we put it this over here, we're gonna have to drill a hole down pretty far. So I could also just put the bolt mounts one here, like here, and then one here, kind of like I did here. I don't love that. I could also put them in front and back, but I still have the same. I have an idea. What if I put them at the very corners, like here and here? That'd be kind of metal looking. Be pretty cyber. So let's consider that. All right, so let's go to the enclosure bottom. So we'll start down here. Let's not view the top or the PCB because we just want to work on this. And let's do a new sketch on the bottom. Boop, boop. All right, so how do we want to do this? So we know that this is going to be, we need these holes to be 3.4 millimeters. So we want to do like at least 6 millimeters off to have enough meat of plastic for the, oh, UPS is here, 1 second. Okay, back to it. So we want at least 6 millimeters, maybe more. Let's create. Let's see. Change parameters. So enclosure. Bolt. What should I call that? Flange diameter? Yeah, flange diameter. Let's start with 3.4. Let's start with 6, and we're gonna play with it. Okay, so I'm gonna offset this. No, I just want. Let's do some. Let's wonder if we can just project these two lines. Project that. Project that, hit OK, and now we're going to offset those two. And I need to make it, let's see, I think I want to make it offset as a construction line. I don't actually know if it matters, but let's say offset that one. Nope, offset that. Offset that, flange, boop. And let's do it again. Let's try to get just that line. Ooh. Come on, come on. There we go. Flange. Okay, so those are offset. And let's draw some more lines. These need to be construction from here to here. From here to here. From here to here, and from here to here. Okay. I'm just thinking about how I want to do this. I'm gonna try something. Let's do an offset from this, just this one. That's weird. Okay, well, let's draw a line from here, perpendicular, and we're gonna offset that. It's gonna be flange diameter. Let's do flange diameter times 2. And now let's do I wonder if I should do an M3. No, we'll stick with the M2s. Just trying some different design. Ideas. It really wants to spin it around, doesn't it? Let's do some real lines. Just so we can do some extrusions here. It's not the worst. Oh, I was not paying attention to the chat. Sorry. Cheers from Barcelona. Hey, that's awesome. Thanks for tuning in from Spain, Barcelona. Trey, does it need to be waterproof? Nah, doesn't need to be waterproof. I mean, the final version, when it's like, you know, professionally plastic molded, maybe it needs to be waterproof, but certainly not this. Certainly not for prototype. And also, all these components are, the moisture doesn't really matter. The only thing that, you know, it's not going to be submerged, so it would really be just kind of a weatherproof thing. The only thing that concerns me is these batteries, and the batteries really should be sealed off. So what cracks me up about these batteries actually is that it's like the worst. This is the worst brand name for a battery chemistry known for catching on fire. Ultra fire. Anyway. Okay, so what do we think about this? I don't know if I love it. I don't know if I love it. It's probably okay, but I'm gonna draw it a little bit different. I don't love the way that I drew it. I think I'm gonna draw a rectangle and then chamfer it. It will give me a little more control over how it's kind of drawn, how we extrude it. So I'm backing off. Okay. I was doing some Control-Z action. Let's draw some lines. Boop, 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 boop. Okay. And let's draw another one here. A line to there. We're going to constrain it. Boop, boop, boop. And then a line. Okay. And do the same over here. Let's draw a line here to here. And constrain it from here to here on that line. Doop, doop. Constrain. Okay. So we need to do some other things. We need to draw a line from center to center here, and center to perp, and I guess I just need center to center, center to center. Let's just draw a line down the whole way. Center. Oh no, I want them center to there to there. And let's put some our bolt hole bits. Okay. Finish sketch. Let's extrude these. Come on, grab the top. I'm gonna grab. There we go. Okay, so those are extruded, and now we're gonna chamfer them. boop, 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 boop. And for now, we're going to go flange divided by 2. And now I'm going to make some holes, make a sketch here, and project in our bolt holes. All right, finish projection, finish sketch, create some holes. Boop. 3.4. Did I do an M2? I really should do an M2 bolt diameter. So I don't have to type it in every time. And we're going to make that 3 deep. Okay, so there are our things. I also need to flange those, all these heat set insert holes. The M2 inserts that we used are not tapered, and so if I flange these holes a little bit, they're a lot easier to put in. So you can see I flange them 0.2 of a millimeter in, and then whatever the length of the hole that they're in is, which is 3 millimeter. So let's do that real fast. Okay, so chamfer 1, 2, 3, 4, 5, 6, 7, 8, and we're gonna do 0.2, and I don't want an equal distance, so 2 distance, 3. Cool. So that should have done them. Let's look. Does it look flanged? It's really hard to tell, isn't it? I think they're flanged. Yep, that's flanged. See how it kind of concave a little bit? Okay, so those are flanged. Those are good. Oh, I'm losing control of my 3D mouse. Save this. Okay, now let's get the top. And let's bring those mounts up. Those bolt mounts up. All right, so we are going to hide the bottom for the moment, and I'm going to put a sketch on the bottom, flip up, and now show the bottom and project in this whole thing. Hit OK, and now let's see, finish sketch. Maybe we'll get lucky and I can just extrude that. Oh, I want to do one at a time, actually, the front and back. So I'm going to extrude these to the top of this. Okay. Oh, but I also need, to, oops, boy, what's happening? I need that and that. let's try that again. So I don't want the hole. I don't want to extrude the hole. Dupe. Okay, and dupe to object top of this. Okay. There's that, and then we're gonna extrude these. Okay, we're gonna have to edit this sketch a little bit. And we need to draw a line from here to there, and a line from here to there. And a sketch. Okay, now we should be able to extrude that. And Z to object to the top of this. Sweet. Okay, cool. And now we need to make some holes. So I need to do, let's go back to, let's make a sketch on, oops. Let's make a sketch on here, on top of this. We're going to project in some bolt holes from below. That and that. Okay, so those are projected in. And then we're going to make a sketch on this one, on the top part. And we're going to project in some more bolt holes. That one and that one. Did those project? I think they did. Okay, cool. And now, I'm going to do some holes. Hey, why can't I select those? A hole and a hole. Huh, maybe because they're not on the same plane. All right, what's the diameter of a head of a 2 millimeter or of an M2 bolt? We got one floating around here someplace. I really think I should make the lid thicker too. Alright, I got an M2 bolt. So I really think I should make the lid thicker because I want to inset these a little bit. So the head diameter 3.6. So I'm going to make a 4 millimeter hole, and then these ones. And the inset 2 down. Okay, so there's our, and actually we got to do something a little bit more. We got to do this counter bore. So this one's going to be 2, and that one's going to be 4, and this is going to be 2.3, and this, the depth is going to be, I want to do to the bottom, so 2 there. All right, there we go. I really should have parameterized some of that stuff. Okay, so that should be good for that. Now we're gonna do the same thing over here. Oh, and we got to make a hole for our screen. That's super important too. I kind of want to make this thicker so that I don't, so my bolt has, because my bolt, I want 2 millimeters of inset so the bolt can sit down in it. But the whole thickness here is only 2 millimeters, right? So that's kind of a problem. My bolt would just sit in it. So maybe I make it 3, lid thickness of 3. But then it kind of is going to interfere with my screen too. Maybe just have the bolt sitting up a bit. So let's do this. Let's do boop, boop, and it's going to go to this side, and we're going to do a counter bore, and this is going to be 4, 1, 2.3. Okay, so the bolt will sit up a little bit. We can massage that later. All right, let's see the whole thing together. It's not looking bad, right? We can kind of chamfer some edges, fillet some edges and whatnot in a bit, but not bad. If let's show the PCB bodies. Turn off the thing. So, oops, that's not what I was trying to hide. Okay, so take the top off. Not bad, right? Boop, 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 boop. Do we have clearance in there? I think we do. I think, yeah, it's the way that it's done. It'll be interesting to print. It should actually bridge that okay, but pretty fun. Yeah, not bad, not bad. All right, let's get our screen in, our screen area. So I want to edit the top, and we're going to do a sketch here on top of this plane. And let's show, we need our, let's turn off our bodies on the top for now. And let's turn off the bottom, just because it's kind of a lot. And in here, we need to get this, we need to project up our screen display area, right? So I'm gonna project in this, 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 and this. Hit OK. Okay, cool. And I think that's it for right now on that. Now we're gonna, so now I'm gonna extrude that to this side, cut it out. Okay, so cut it. So now now I'm gonna do I wanna chamfer the inside of this. Boop, 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 boop. Because recall, I had this, see this angle, that's chamfer. Equal distance, and this is going to be thickness, closure wall thickness. There we go. Look at that. Very nice. Very nice. Cool. The bodies are off or something? No. Oh, it's there. It just doesn't show up very well. Let's do something there. Let me turn off the top and save. Go to appearance. Let's put some glass in there. So glass. Frosted light color blue. Oh, let's just put that right there. Done. I kind of want to separate that body, right? Let's do something here. Let's unappearance that. Let's go to the PCB. Let's go figure out where we extruded that. It's this one, I think. And let's edit that and say operation new body. Okay, cool. And now when we do our appearance, glass, heavy color blue. There we go. Close. I just wanted to see, it's just a little better view. Very nice. Coming along, coming along. So let's do some cleanup. I want to do some chamfering. So enclosure top, select that, edit, chamfer. Now let's make a parameter for chamfer use. So let's do enclosure chamfer. Let's start with 1 millimeter for now. Chamfer, and we're going to do this all these edges. And I think I want to do that one separately, and I'll show you why. So what do we call this? Enclosure chamfer? Not bad. Not bad. Let's chamfer this one, and let's double it up. We'll see. Chamfer this. Chamfer times 2. Times W? No. Jesus. Chamfer times 2. I don't know if that's a super successful design decision there. Let's try something. Let's try something again. I think we're gonna cut through the wall. Yeah, we cut times 3. Let's see. I don't know, maybe it should be the same chamfer as everything else. What do you folks think? Yeah, we're gonna delete that. Chamfer. Oi! I knew it was too good. I knew we were cruising along too well without a crash. It'd been like, an hour since we crashed. Okay, I'm almost out of tea, so I think we're almost done with the stream. When the tea's over, so is the stream. Let's open our recovered dock. Oh, look at that. Didn't get any of my chamfers. Okay, well, let's go back to it. Enclosure top. Yay, technology, definite check. Yup. Technology. Okay, we're just gonna try chamfering again. Okay, and now. Oh, I don't even have the thing anymore. All right, let's just put it in. Was it 1? Okay, so let's go. Let's save this. Modify, change parameters. We're gonna do. Watch this not work because I chamfered before I added the parameter. Enclosure. Chamfer 1. Save. Okay, so if I edit this, I wonder if that'll be available. Yep, it is. Okay, sweet. Cool. Cool. Not bad. Not bad. Looks pretty good, right? I got a couple more things I want to do. The first is I want to chamfer the bottom as well. So we're going to select this, and we're going to do chamfer, boop, 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 boop. Cool. So that's good. Got a nice chamfer there. This looks pretty good, right? That's not a bad enclosure for this thing. You know, not super different from the Vision here. Let's do some side by side. Boop, 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 boop. There we go. So, you know, initial sketchy vision and actual, it's not so bad. So I got one last thing I want to do. I want to put a Powered by Meadow logo on here. So we're going to select the top, boop, and I want to do, let's see, how do I do this? I got to remember, I think I do a sketch. Do a sketch. Quit spinning around. And I do insert SVG. We've got to find an SVG, insert from my computer. Google Drive. Okay, shared drive, design, assets, logos, made for Meadow. There's this powered by, made for Meadow. What happened to our powered by? Pretty sure I have a Powered by Meadow logo. Let me find it. Google Drive, boop. Share drive, design, assets. I thought it was in here. Made for Meadow. Wasn't in here? What is this made for Meadow? That's not what I want. I want Powered by Meadow. All right, let's start with a Meadow logo. Horizontal, mono, H, where is it? Okay, let's do, we gotta do clearly 80, and scale is gonna be 0.1, let's try that, 0.2, I just drag it around. Yes, Meadow. Say okay. Okay. Oh, that didn't quite work, did it? I think I have one of these that I cleaned up a bit. Might have to, let's see, Meadow logo mono. I don't think I have Sketch installed. I got a new computer a few months back and I haven't installed anything. Okay, well, maybe we won't brand it quite yet. I will put this Powered by Meadow in there in a bit, but I have to go make the logo and then clean it up and put it in, and that requires me to install some applications on my computer, which no one wants to watch me do. So I think we're done. I think this is yeah, this looks pretty good. I'm pretty stoked on this. I'm pretty happy with this. I'm gonna I'll get it. Let's get it printing. So let me show you how I do that. This actually should be an interesting thing because I unplugged my thing that reads compact flash drives. Okay, so we're gonna make this for printing. So I'm gonna go to Utilities, Make, and then we're gonna select the bottom. Output to STL, don't send to their silly 3D print utility. Put this in temp, GPS enclosure bottom, save, simplify 3D, and remove imports, temp. Marmot's eating carrots. Okay, I have to take a detour, just for science. There's this thing that I found the other day called Diffusion Bee, and it's a standalone desktop app for stable diffusion. So this is funny. So Stable Diffusion is an AI library thing that allows you to type in some text and then it'll create an image. So I did Marmot's eating carrots in an alpine meadow, and it generated this. So that's where my mind goes. So while I set up the Simplify 3D, how about someone in the chat tell me what you want me to generate, and then we'll get that generating. All right, so hold down GPS enclosure bottom. So there it is. That looks good. And let's see. I think we're all set up for my PLA. Okay, prepare to print. Prepare to print. My name is Bryan Costanich. Prepare to. You designed my enclosure. Prepare to print. Okay. Enough of that. What? Nobody's got any ideas? Okay. How about 6 developers hacking on printed circuit board. All right, let's generate that. Okay, we exported. Did we save this to disk? I think we did. Yep, replace. Okay. Eject that SD card. Let's get it plugged into the printer. Okay, and that is that's starting. Let's see what stable. Look at that. So this is just an AI generated image. Not bad, right? It's not 6 developers, but it's definitely it does look like someone hacking on a printed circuit board. Anyway, Diffusion B, stable diffusion. So you too can generate Marmot's eating carrots. All right, folks. This was a lot of fun. This is a good stream. It was a long stream, but we got a lot done on it. My webcam kind of sucks right now, but let me switch back. So this is what we built. We built this awesome 3D enclosure based on this Easy EDA design that we did. Here it is. That's our circuit board. Can't see all the stuff that is interesting, but in any case, yeah, we built this really nice enclosure. Hopefully it'll fit. I should get the circuit board in next week, and it'll take us probably a week or so to assemble that. We've got a bunch of other stuff that we're assembling right now. All the new Klimas are getting ready to go out, and then our dev, our core compute dev boards and core compute modules are also like everything. It's going to be the great shipping of September. So we're assembling all that stuff first. But when I get this board assembled, we'll drop it in here, and then we'll see how everything fits, and then we'll make some adjustments. So thank you for following along, and I hope this was helpful, useful, and entertaining. And I'm not sure what I'm going to be up to next week on here, but I will definitely be streaming. So thanks everyone for joining in. I really appreciate having some company, and we'll see each other next week. All right. Adios.